Cycle 1, Lesson 11, we are going to move on again to a new type of function for Cycle 1, and we're going to, our last, 4 lessons are going to have to do with trigonometric functions. So before we get to the trig functions, though, what we're going to do is we're going to introduce a new way of measuring angles, new to you anyway. And so up till now, you've been familiar with using degrees to measure angles. Now we're going to use something called the radian. Radians are another unit of measure for the size of an angle, right? So instead of saying something is 180 degrees before, as we used to say, we might say that something is 3.14 radians. And so just like any kind of angle, or any kind of measurement, like any kind of measurement, we can convert it. Think about kilometers and miles. We have a distance in miles, we use a conversion factor and we can convert it into kilometers. Or if we have a distance in kilometers, we can change it to miles using the conversion factor. This works for any kind of measurement, meters and feet, and so on. In math and physics, there's lots of applications that use pure numbers, which is what radians are, and they're more convenient than using degrees. So, what's a radian? A radian is the measure of an angle which is subtended at the center of a circle by an arc equal in length to the radius, which we're going to represent with the letter R of the circle. Therefore, the measure of an angle in radians is simply the ratio of the arc length of a circle to its radius. Hence, it's a length. Okay? So a radian is a length. So, if we take a look at this picture here, then we can see that we got a circle and it's got a radius. It doesn't matter what the radius is. It could be 1 meter, it could be 3 centimeters, it could be 55 miles. It doesn't matter. It's got a radius. So whatever that radius is, we're going to then use that radius as a measurement. So if I take this radius, imagine that I'm laying out a string along this radius here as I highlighted in red. Then I cut it to the right length and I pick up that string and then lay it along the outside of the circle. So these two parts now that are highlighted in red are both the same length. One of them's in a straight line, the other one's curving around the outside, but they're the same length. Well, the angle here in the middle is what's called the radian. So the angle, when you take the radius of a circle and go around the outside with it, then you've got this angle, we can call it theta, is 1 radian. And again, it doesn't matter what the size of the circle is, because the ratio of the radius to the curved part is always going to go the same distance around as an angle. So, for 1 complete revolution, the length of the arc equals the circumference of the circle, right? And the circumference of the circle is going to be 2 pi. Radians are represented as a fraction or part of a circle, and 1 complete revolution measures 2 pi radians. So, obviously, if we want to work with both of them, we're going to have to be able to convert from degrees to radians, and we're going to have to be able to convert from radians to degrees. So, some basic conversions we need to know is that half a circle, and let's draw an actual circle here. So if here's a circle, half of a circle, put it on a Cartesian plane. That'll make things easier still. If I were to go halfway around a circle, then that's 180 degrees. And that's actually equal to pi radians. So pi radians equals 180 degrees. And if I was to go all the way around a circle, then that's 360 degrees, and that's equivalent to 2 pi radians. So the most basic multiplication factor we want to use is this one, pi equals 180. So again, think in terms of, you can say 1 mile equals 1.6 kilometers. That's sort of our benchmark that we use when we convert. So pi radians is equal to 180 degrees, or 180 degrees equals pi radians. So since they're connected to each other, they're basically just two ways of doing the same thing. An easy way to convert from radians to degrees is to multiply by, if I want to go from radians to degrees, I do 180 over pi. Use that as a multiplication factor. So for example, if I had 1 radian and I wanted to know how many degrees that was, is going to be 1 times the 180 over pi. And when I type that in my calculator, I get 57.3 degrees. So if you remember back here, the sketch I drew, that was already drawn, but we filled in, that looks like it's, it's to scale. That looks like it could be 57.3 degrees in here. So 1 radian is equal to 57.3 degrees. If I want to convert from degrees to radians, I'm just going to go opposite. So I'm going to multiply by pi over 180. So I just flip that fraction around. So for example, if I had 360 degrees, I could take that and multiply it times pi over 180. And when I simplify things, I could reduce 180 goes into 362 times. So I'm left with 2 times pi. And so 360 degrees equals 2 pi. We're going to do some more examples to hopefully drive that home a bit more. So if we're switching from degrees to radians, like the very last thing I did, let's take a look at some other ones. If I had 30 degrees, I can multiply that by pi over 180. And if I want to get an exact value, then I can just reduce and leave it as a fraction. So 30 goes into itself once, so it goes into 180 6 times. So I'm left with pi over 6. So pi over 6 is an exact value. It hasn't been reduced or rounded or anything like that. So that is an exact value for radians, but it may not mean a lot to you. So if we were to change it to a decimal, if I was to take pi, 3.1415, and divide it by 6, I get approximately 0.52. Now that is rounded, that is chopped off, so it's not as precise, but it probably gives you a better idea of what's going on. So if this sketch up here, again, was pi radians, or 57 degrees, then 30 degrees is going to be about half of that, so 0.5 radians, which is, again, what we saw here. 120, just to predict a little bit, if we know that 1 radian is approximately equal to 57 degrees, then we would expect that 120 degrees is going to be approximately equal to 2 radians, right? But to get a more precise answer, again, I can reduce this by 60 degrees, I get 2. Reduce 60 goes into this, I get 3. So I end up with 2 pi over 3 radians. And then as a more precise answer, again, if I were to do 2 times pi divided by 3, like literally, let's go to the calculator here just to show you this, just typing it in. 2 times, is there a pi button on this? Yeah. pi divided by 3 equals 2.0943951024, or rounded to approximately 2.1 radians. So these two things are equivalent. 2 pi over 3 is approximately the same as 2.1, and that's how many radians in that angle. So 500 times pi over 180. When I reduce, I can divide each of these by, 20 will go into these. 20 goes into 500 25 times. 20 goes into 180 9 times. And so I'm left with 25 pi over 9, which if I want to reduce or change to a more approximate answer is 8.7 radians, approximately 8.7 radians. So that's going one way. Going the other way, remember, I'm just going to flip the fraction upside down and multiply. So pi over 5, again, that's a specific amount of radians. If I were to take pi, divide that by 5, then that's about 0.63 radians, but we'll leave it as a fraction. And we're going to multiply it by the conversion factor of 180 over pi. So we're flipping the fraction upside down, and the pi's cancel out, and 180 divided by 5 is equal to 36. And so it's going to be 36 degrees. And then we just do the other ones the same way. Pi over 120 times 180 over pi. Pi's cancel out. I can reduce this. So 120, 60 goes into this twice, 60 goes into this 3 times. So that's going to be the same as 3 degrees. Sorry, 3 over 2 degrees. I would write that, of course, as 1.5 degrees. I wouldn't write my degrees as a fraction, but that's what it would be. 2.4, again, this is radians, so it doesn't have to be written as a fraction. I can start with a decimal. 2.4 times 180 over pi. In this case, I'd probably just type it all in my calculator at once rather than trying to reduce the fraction, since I've got fractions and decimals combined. It works out to 137.5 degrees. So we can convert either way, just like we can convert any distance or length either way. Okay, we can also use this radian ratio to help us find other unknowns, because it forms a formula, a simple formula, and we can use the arc length of a given angle in radians to do this. So here's the basic formula that we need to know. Let's put a box around that because it's pretty important. And that was supposed to be a box. Let's try again. Not boxing it up for me. All right, well, we'll leave it then. So theta equals A over R. So the angle, again, if we have a circle, not quite perfectly round, but close enough. If we have a circle and we got some angle in there, theta, let's say, for argument's sake, that our angle is over here. And so we've got this angle theta here. And we have the radius, which I've drawn a green line represented by R. And we've got the arc length, which is going to be this whole thing here I'm doing in purple. That's A for arc length. I should move this theta because it's kind of confusing where it is. Try and squeeze it in here instead. So theta's in there. The angle theta is equal to the arc length divided by the radius. So that's our basic formula. We could rearrange it then. If I wanted to isolate arc length, for example, I could multiply both sides by R, and I get r times theta, and I could isolate r as well if I needed to, but depending on what question we're looking for, or what answer we're looking for in a question, then I can just use that basic formula rearranged. So let's look at one. Suzette chooses a camel to ride on a carousel. So a carousel goes around in a circle, right? The camel is located 9 meters from the center of the carousel. Well, that's good to know, because if it's 9 meters from the center, that's giving us the radius, right? R equals 9. 9 meters, let's include units. If the carousel turns to an angle of 150 degrees, determine the length of the arc traveled by the camel to the nearest meter. All right, so we know that the radius is 9 meters. Theta, we know in degrees. We know that theta equals 150 degrees, but in order to use this formula, this theta equals A over R formula, it has to be in radians. So we're going to have to convert that into radians. But how do I know? Do I multiply it by pi over 180 or 180 over pi? Because you might not remember that. Here's how you remember. I know I'm going to do pi over 180 as my conversion, because I want the degrees to cancel out here. So I can think of this even as 150 over 1. I want to cancel out my degree units. So if I have 180 on the bottom, that's going to do that. And I can see that 30 goes into 150 5 times, and it goes into 180 6 times. So as a fraction, I can write it as 5 pi over 6. Or I could change that to a decimal. 5 times pi divided by 6 equals 2.62 to 2 decimal places. And there's no units on radians. Radians are a unitless measure. All right? So now I've got r and I've got theta, so I can then find out what A, the arc length, is by doing r times theta. And so it's 9 meters times 2.62. And I just, even though I rounded it when I wrote it down, I left the 2.62 and all the other decimals after it. So I've got a more precise answer of 23.6, if I round to 1 decimal place, meters. There should be decimal there, 23.6 meters. That's the answer we're looking for. So Suzette got on the camel, on the carousel. It started up. It went 150 degrees, which is about 2.26 radians around in a circle. Obviously, the camel has been going around in a semicircle, going around, and the distance it's covered is 23.6 meters.